Now in this part we'll start defining some more interesting functions, and in Haskell, recursion is very often the way to go. Recursion is important in Haskell. And just to give you a very first glimpse, let's look at the factorial function. N factorial is, as we know, the product of the natural numbers from n down to 1, so it's n times n minus 1 times ... all the way down to 1. And how can we define the factorial function in Haskell? It's not hard to see that we have that n factorial is n times n minus 1 factorial. How do we see that? Well, if we look at the above, then what we have here is the product of the numbers from n minus 1 all the way down to 1. That's n minus 1 factorial. We also need to have a base case. We define 0 factorial to be 1. And these two cases together give us the blueprint for a recursive definition of the factorial. Let's see how we write that in Haskell.
So now let's try to use what we've just seen to define the factorial function. And what should the factorial function be? Well, it should be a function fac, that for any given n, tests if n is equal to 0, and if that's the case, it should return 1, else we return n times, and this is where the recursive call comes in, the factorial of n minus 1. Then one might ask, what is the type of fac? In a moment we'll see what the type is according to the Haskell system, but a good guess is that the type of fac should be, well, let's see, we would expect that for any number type a, so if a is a number type, then the type should be a. We would to a because we take an argument of type a and we return a value of type a. What else do we need to know about the type? We also need to know that we can compare values of this type to 0. So a should also be in the type class EQ. So we say if a is in the type class EQ and if a is in the type class num, then the type of the function is a to a. Let's see if that's the case. Let's try to save this and send it to Haskell. Everything works out fine. Let's try to delete this type annotation, send this to Haskell again. Everything's still fine. What does Haskell say about the type of fac, :tfac? Ah, the type that we expected. Now isn't that nice? I certainly think so.